All right, guys. Today we want to talk about chapter 2. Um, it's a little different. I told you the other day it was basically math. But first I want to talk about chapter 2 and the standpoint of stuff that we've kind of already dealt with a little bit. Remember the other day when we were measuring and looking at the meniscus and trying to figure out where we needed to read, and we weren't always sure about the numbers? That's what we want to talk about for a few minutes today. I want to talk about something called uncertainty in measurement, okay? And to look at when we're measuring things, because that's what we're going to be doing in chemistry, is to, when we measure something, how can we look and know what amount of material that we have, okay? So I want to talk about that kind of thing called uncertainty. What do we know and what we don't know when it comes to measuring these particular items, whether it be volume or mass or whatever we're measuring, or temperature, things like that. So anyway, the first thing is a digit that must be estimated. You remember we kind of did that the other day with that, looking at the meniscus and estimating where it was at. But any number that must be estimated is called uncertain because we're not exactly sure what it is. So here's the thing though. Every time we take a measurement, there's always going to be some degree of uncertainty. Always, okay? So it doesn't matter if it's a big number or a small number. We're never going to be completely 100% sure what that number actually is, okay? So my question is why? Why is there uncertainty in measuring materials? There's got to be some reason for it, right? Well, it's actually pretty simple. You start thinking about why we can't be certain of the numbers that we're getting, well, we can't be 100% sure why. There's actually a very simple reason. And it has to do with the things that you're measuring. The instruments that you measure with are the problem, okay? You perform every measurement you take, whether it's length, whether it's volume, whether it's measuring mass, whether it's measuring temperature, you're measuring those with instruments. And here's the Duhon statement for today. No instrument can measure to an infinite number of decimal places, okay? Y'all all know what infinity is, right? Forever. Well, there's no instrument that can measure that. No instrument is so well designed that it can measure the length of something to infinity and get it correctly, perfectly, 100% right. You just can't do that. Okay? So I want to ask you a question. Which of these balances has the greatest uncertainty in measurement? So if you look at these three balances I'm about to put up here, which one has the most uncertainty? Would it be this one? Would it be this one? Or would it be this one? Which one of these three is the most uncertain? Well, if you look at this one is measuring to decimal points. That's a digital scale. This one, as you can see, is a little bit certain, but it's got some issues with it, right? Now again, you can get, I think, to tenths of a gram here. This guy right here, you see these at the supermarket, can't you? You see these in some of your kitchens as well. These are not very certain. So this one right here has the greatest amount of uncertainty. This one, however, has the most certainty, doesn't it? It has the lowest amount of uncertainty. This is the one that's the one you want to use if you want to come up with the closest number that you're supposed to get. Okay? So that's why there's always uncertainty, because it doesn't matter if you have this instrument or this instrument, they're not going to be 100% certain. You can't get certainty to infinity. It's not going to work. You just can't do it. Okay? Now, that leads us to two words that you may or may not have heard of, but a lot of people get them confused. They think they're the same word, or they mean the same thing, and they don't. Precision and accuracy. Okay? Is there a difference? And here's the Duhon statement. I wouldn't have asked if there hadn't been a difference, right? So, let's look at this. Precision versus accuracy. Well defined, accuracy refers to the agreement of a particular value with the true value. Do what? What does that mean? Okay. Accuracy refers to the agreement of a particular value with the true value. In other words, how close I am to what I'm supposed to get. You know, it's like shooting an arrow, right? How close am I getting to the bullseye? The closer I get to the bullseye, the more accurate I am, okay? But if I talk about precision, precision refers to the degree of agreement among several measurements made in the same manner. And you're like, what does that mean? That means if you're doing it more than once or twice, how close are they to each other? And I'm going to show you what I'm talking about right now. Let's look at these three right here. Here it is, 3 arrows being shot at a dartboard, right? Or a bullseye. You look at these three. Is this accurate? Or is it precise? Or is it both? Or is it neither? Well, if you look at it, are they hitting right here? No. They're hitting here, here. Are they hitting close to each other? No. This one is neither accurate nor precise. They're just all over the place. This looks like something I would end up doing. They'd be all over the place. It wouldn't be where they're supposed to be. Okay? But if I look at this next one here, is this one accurate? Or is it precise? Both or neither? Well, if you look at it, are they accurate? Are they hitting the bullseye? No. Where are they hitting though? If you look real close, they're all hitting in the same area, aren't they? Now we want to hit here, but we're hitting all right here. We're not accurate, but we are precise. We're precisely hitting the same spot. And this would be a lot of times like if you're using a rifle or something, your sight isn't being played with right, and it's off. And every time you're shooting, you're hitting it at the same spot, but it's not where it's supposed to be, and you got to correct it. It's just like when you guys play basketball, right? And you start aiming and you shoot, right? Well, the problem is, what if you keep shooting and shooting, and it's always just a little bit to the right length, it's the perfect length, but it's just always a tad bit to the right. Well, you're going to have to make an adjustment where you move a little bit more to the left so that you can ring the basket, right? It's the same idea. And then this last one here has to do with both, right? We're both accurate because we're hitting here, right in the center, but we're also precise. Everybody's hitting in the same spot, which happens to be where we're aiming for. So you can see the difference between accuracy and precision. Precision, but no accuracy. Neither accurate nor precise. Okay? So you do see the difference between precision and accuracy. Okay. Now, that leads us to, well, what happens when we're doing experiments? Because again, we're going to be doing experiments, and we're going to have issues with the experiments. Because every experiment you ever do, there's going to be problems, always. I don't care how good you set up everything, there's always going to be issues. And there's basically two issues that you have as far as error, things that are going wrong with your lab, with your experiment, okay? The first one is something called random error. Now, sometimes you'll see the word indeterminate, which means you can't determine what's causing the problem. It's a measurement that has an equal probability of being high or low. Sometimes we're a little up, sometimes we're a little low, left or right, whatever. That's random error. Now, you and I know this already. We can already figure this out. You, as a experimental person, cannot fix random error. That's why they call it random error. You don't know what's causing it, and you can't really fix it. It's just something that happens. However, the other type of error, which is called systematic error or determinant error, means you can determine what's the problem. Okay? This occurs in the same direction each time, high or low, often resulting from poor technique or incorrect calibration. Remember what I said? If you have a sight on your rifle and you're always aiming and you have to shoot it and it's always going a little bit to the right where it should, you have to recalibrate your sight, don't you? That's a systematic error. That's something that's going wrong every time because what you're doing is wrong. You got to fix this one thing, this problem. And then hopefully you will stop the systematic errors, and again, random error just occurs. You can't really control that. Okay? So this is the basics of uncertainty, right, in measurement. Now in the next lesson, we're going to look at how we measure things and how we come up with the numbers that we're coming up with. And it deals with how uncertain or certain we are of a specific number. All right? And that's called significant figures. Okay? So that's what we'll take a look at in the next lesson.